Look at these domes, these stone petals, these impossible patterns going deep into the ceiling. For years we have been told the same thing. Ancient craftsmen simply took a hammer and chisel, stood under the dome, and carved every line by hand for decades. But was it really that simple? Do you seriously believe that the thinnest ornaments, deep cavities, perfect symmetry, and complex curved forms were created by rough blows against stone? Without mistakes? Without cracks? Without chips? Without visible joints? This is where the most uncomfortable part of the story begins, because the closer you look at these temples, the stronger the suspicion becomes. Perhaps what we see is not ordinary carving on a monolith. Perhaps ancient masters worked with a material that was first soft, obedient, almost alive, and only later turned into stone. Yes, it sounds bold, almost scandalous, but this version explains what the usual stories cannot explain. How did they work under a ceiling with such precision? Why are the traces of impact carving not obvious? Who could pay for decades of such work? And why do modern craftsmen, even with electric tools, often fail to understand how to repeat something like this without a different technology? Today we will examine a version after which Indian temples may no longer look like what tourists are usually shown. Watch this video to the end, because next come the details that can overturn the usual view of ancient carving. Stone-like plaster, liquid glass, secret craft recipes, lost schools of masters. And the main question that becomes deeply unsettling: what if the ancients did not carve stone, but created it? And this is where the most uncomfortable question begins. How could all of this be carved on the inner dome of a temple? Not on a table, not on a separate slab, not on a convenient horizontal surface where a craftsman could calmly control the tool. We are talking about a ceiling, about height, about work above the head where every strike, every movement, and every extra millimeter could ruin the entire pattern. We are asked to believe it was made in the ordinary way: hammer, chisel, hands, patience. A convenient version, but far too smooth for such brutally complex work. Look at the structure of this carving itself. This is not a flat ornament that can be scratched onto the surface and presented as decoration. There are thin petals, recesses, inner cavities, curved depressions, and lines that go into the stone at an angle. Some elements seem to hang over others, some appear hidden in depth, and others demand perfect circular symmetry. And all of this was supposed to appear not somewhere at the side, but directly above the craftsman's head. This applies to those ceiling domes where the decorative part does not look like simple carving, but like a complex stone structure inside the surface itself. It is not enough to say, the ancient craftsmen were patient. Patience does not explain razor-thin bridges, the repeated rhythm of elements, and precise depressions that look as if they were shaped, not hammered out. This requires not only labor, but technology. The main oddity is that, according to the usual version, the craftsman had to work in an extremely uncomfortable position. Arms raised upward, tool aimed at the ceiling, eyes constantly checking a complicated pattern, and the body under tension for hours. Try to imagine doing such work for even one day. Now imagine that the task is not simply to remove extra stone, but to create perfect petals, deep channels, and thin edges without chipping anything. This is no longer craft in the ordinary sense. It is an almost impossible marathon against the material. And here comes another hard question. How did they control the depth? In stone, a mistake is never light and harmless. If the chisel went slightly too deep, a thin detail would break. If the angle was wrong, symmetry would be ruined. If the strike was stronger than needed, a chip or crack would appear on the surface. And the dome is not a small decorative tile that can simply be thrown away and replaced. This applies to the most dangerous part of the work: inner corners, cavities, and areas where the carving seems to move inward. These are exactly the places where ordinary tools work the worst. A hammer and chisel are useful where there is direct access and a clear direction of force. But how do you carve a complex curved line from inside a ceiling surface without destroying the neighboring thin element? This is where the beautiful legend of purely manual work begins to sound too confident. The explanation about primitive tools looks especially suspicious. This phrase is often used as if it explains everything by itself. But a primitive tool does not create complex geometry on its own. It does not guarantee identical circles, even rows of petals, or clean inner cavities. If the tool was truly simple, then the technology behind the work had to be far smarter than we are usually told. The problem is also one of scale. It is one thing to carve a small fragment at eye level. It is another thing entirely to work across a whole dome, where the ornament is connected into one composition, and a mistake in one place immediately damages the impression of the entire surface. This cannot be explained away by saying the craftsmen were experienced. Experience helps the hand, but it does not cancel physics, awkward posture, the risk of chipping, and limited access to the surface. So the question remains open, and it is extremely inconvenient for the simple version. How exactly were these petals, cavities, and curved depressions created? What method allowed a craftsman to work under a ceiling with such precision, as if the material itself obeyed his hand? Why are we required to believe that all of this was hammered for years out of solid stone, when the very shape of the relief hints at a completely different process? Perhaps what we see is not the crude victory of a chisel over stone, but the trace of a much more cunning technology. Even if we remove the romantic fog of antiquity and place a modern craftsman next to these domes, the question does not disappear. Give him an angle grinder, a rotary tool, an oscillating cutter, a set of bits, sanding heads, laser marking, scaffolding, and proper lighting. Most likely, he would still look at that ceiling and say a blunt thing. You cannot take on this job without understanding the technology. The tools are there, but the clear method is not. Modern electric tools can cut, grind, remove material, and clean edges. But they do not cancel the main problem. The work has to be done on a dome, inside a complex surface with extremely thin details that can be ruined by one unnecessary movement. An angle grinder is useful for straight cuts, rough removal, and surface preparation. But how can it produce an elegant petal, a deep cavity, an inner curve, and a small ornament right next to finished elements? One wrong touch of the disc, and instead of sacred beauty, there is a crude scar. This applies to areas where the carving does not simply sit on the surface, but goes into the stone. It is not enough there to trim or polish something. The worker has to remove material at an angle, leave a thin edge, preserve symmetry, and avoid touching the neighboring element. Even modern equipment in such a place turns not into a magic wand, but into a source of danger. A rotary tool does not solve the problem either. Yes, it can work more delicately. Yes, it can reach smaller details, but try holding it above your head for hours, at height, in dust, near fragile edges of a future pattern. The hand gets tired, the bit slips, the stone chips, and the area that should look like perfect stone fabric suddenly becomes a damaged spot. That is why talk about simple ancient tools sounds far too confident. If today, with electricity, diamond bits, industrial materials, lifts, protection, and precise marking, this work still looks like a nightmare for a craftsman, why are we so easily asked to believe that in the past it was done almost with bare hands? Why is the complexity of the result reduced to one comfortable phrase? The craftsmen were patient. This applies not to rough stonework, but to jewel-like labor on an architectural ceiling. You cannot swing a tool there as if you are at an ordinary construction site. Every movement has to be calculated. The task is not merely to remove excess material, but to create depth, rhythm, shadow, repetition, and visual cleanliness. The scale is especially inconvenient. One decorative fragment can still be explained by long manual labor. But when the carving covers an entire dome, when the ornament repeats in a circle, when dozens of elements obey one central composition, the version of slow chiseling begins to sag. How many craftsmen were needed? How did they synchronize the pattern? Who corrected the mistakes? How was a damaged area replaced? And most importantly, why do the traces of the process not look like the result of crude violence against stone? A modern master facing such a task would first ask for a project, drawings, templates, access to the surface, test samples of the material, and a guarantee that a damaged section could be restored. Now imagine an ancient craftsman who was supposedly handed a hammer and chisel and told, "Carve thin petals, cavities, and curved recesses inside this dome so perfectly that centuries later people will not understand how you did it." Too convenient for a legend, too heavy for a real working method. This applies to the very core of the dispute, not to the talent of the craftsman, but to the method of execution. No one needs to deny the high skill of ancient artisans. The real question is different. By what exact method did they achieve such a result? If modern tools do not give an obvious answer, then perhaps the matter was not the force of the strike or the number of years, but a completely different principle of working with the material. That is why comparison with today's tools hits the usual version harder than any beautiful phrase. We live in an age of machines, electricity, precision bits, and construction chemistry. Yet even now, such a dome remains a technical challenge. That means the ancient craftsman either possessed an incredibly well-developed carving system that is almost never explained to us, or they worked not on hard stone, but on a material that, at the moment of processing, was much more obedient. And this is no longer the romance of antiquity. This is a harsh technological question. If a modern craftsman does not know how to perform such work safely and quickly in stone, why should we believe that thousands of years ago everything was solved only by a hammer, a chisel, and patience? Perhaps what we see is not a miracle of primitive labor, but the trace of an intelligent technology that later generations simply stopped understanding. This problem is often covered with one convenient phrase: the craftsman had plenty of time. Decades, generations, endless patience, sacred labor, devotion to the temple. A beautiful formula, but it has one brutal weakness. It explains almost nothing. Time by itself does not carve a dome, does not steady a craftsman's hand, does not protect thin elements from chipping, and does not answer the main question: who paid for all of it? Work of this level could not have been a cheap pastime. This was not a village wall that could be raised together after the harvest. We are looking at extremely complex architectural decoration that required top-class craftsmen, assistants, materials, scaffolding, lighting, food, protection, constant supervision, and precise organization. If the carving was truly done for years or even decades, then someone had to support an entire group of specialists all that time. At whose expense? This applies to the most uncomfortable part of the usual version: the economics of the process. Any major construction project is built not only on inspiration, but also on money, food, time, and people. A craftsman must be paid, apprentices must be fed, materials must be delivered. The workplace must be maintained, and if the result appears only after 10, 15, or 20 years, the patron must have iron patience and enormous resources. Fans of simple explanations often speak as if ancient craftsmen could sit under a ceiling forever, chiseling ornaments for one noble idea. But people in every era needed food, families, payment for labor, and visible results. Even the most religious patron could not allow an endless construction project without a clear completion date. A temple was not built for a beautiful report half a century later. It had to function, receive people, display power, show the wealth of the community, and strengthen the prestige of its sponsors. And here comes the question that is usually avoided. What happens if, after several years of work, the craftsman makes a mistake? One thin petal breaks, one inner edge chips, one strike goes in the wrong direction. On an ordinary decorative piece, this is a problem. On a single ceiling dome, it is a disaster. Should the whole dome be discarded? Should the section be rebuilt? Should the work begin again? Or should everyone pretend that it was intended that way? This applies to the risk of defects, which is almost never discussed seriously. In hard stone, a mistake cannot be wiped away with a finger. It cannot simply be smoothed over like fresh mortar. If part of the relief is damaged, the trace remains, and in a complex, symmetrical ornament, one flaw immediately stands out, especially when the entire pattern is built on repetition, precision, and balance. The version about long years of manual work becomes even weaker when we remember the scale of such temples. We are not talking about one ceiling rosette. We are talking about columns, walls, arches, friezes, niches, and domes, where carving seems to flow across the stone in one continuous stream. If every element was made slowly, with a chisel, under a ceiling, and with a huge risk of failure, then construction would have turned into a bottomless pit of money and time. And again, a rough but honest question appears. Why? Why spend half a craftsman's working life on a section that could have been created faster with another technology? Why risk a finished temple if there was a way to shape relief on a plastic material? Why explain everything through patience when the result looks more like work with an obedient mass than a decades-long battle against stubborn stone? The usual version loves the phrase "decades of labor" because it sounds safe. It does not require anyone to search for forgotten recipes, examine compositions, check layers, analyze tool marks, or ask uncomfortable questions. But beautiful words do not replace technology. Time is not a tool. Patience is not a method. Decades do not explain how the craftsman controlled the form, corrected mistakes, and preserved the perfect cleanliness of the ornament at height. So the explanation, "they had plenty of time," looks less like an answer and more like a screen. Behind it hides a much more serious problem. We do not know the exact method used to create these works. And once that honest thought is accepted, the whole picture changes. What stands before us is no longer just slow manual labor, but possibly a technology where speed, precision, and repairability mattered far more than the legend of endless patience. If a finished stone dome is struck again and again with a hammer and chisel, the result is not a poetic image of ancient labor, but a harsh technical problem. Every strike creates vibration. Every vibration travels not only into the point of contact, but farther, into neighboring areas, into joints, into weak spots, into the structure itself. And if the work lasts not a day or a week, but months or years, the question becomes brutal. Why is the surface not covered with signs of stress? Stone does not enjoy endless blows, especially when we are not talking about a massive block lying on the ground, but about a ceiling dome that belongs to an architectural structure. There is load, geometry, weight distribution, and places of connection. If such a system is hammered for a long time, consequences should eventually appear. Micro cracks, chips, weakened areas, visible joint lines. This applies to those temple surfaces where the ornament looks whole, dense, and strangely calm. There is no obvious battle between material and tool. There are no crude traces of constant beating, reworking, and correction. Everything looks as if the pattern was not forced out of the stone, but shaped in an already prepared mass. The question of joints is especially important. If the dome was assembled from separate stone blocks, then long impact treatment should have revealed the connecting lines. Vibration does not spread perfectly. It catches on material boundaries, differences in density, and weak lines. A joint is always a potential place where the surface can reveal its construction. But if the joints are not visible, an uncomfortable fork appears. Either we are looking at a real monolith, worked with incredible precision, or a continuous layer of material was applied on top, covering the structural base and becoming the working surface for carving. And the second option no longer looks like fantasy, because it explains the unity of the decorative layer far better. This applies to the core of the hypothesis. Perhaps the carving was not done on the load-bearing stone masonry, but on a special composition applied over it. Such a layer could hide the joints, level the surface, give the craftsman a convenient field for work, and after hardening, turn into a strong stone-like shell. Then the main oddity disappears. Why long impact work did not leave the destructive traces we would expect. If a craftsman works on hard stone, he is forced to knock material away. He attacks the surface. He depends on the direction of the strike, the grain of the stone, hidden cracks, and accidental chipping. But if he works on a plastic composition, the logic changes completely. He does not strike, he shapes. He does not destroy, he forms. This is exactly where the version of a plaster-like layer becomes dangerous for the usual explanation. It removes several problems at once. There is no need to hammer the finished masonry for years. There is no need to risk cracks in the supporting structure. There is no need to carve thin elements out of stubborn stone. A composition can be applied, worked at the right moment, and turned into a relief that, after hardening, looks like stone carving. Of course, this does not mean ordinary white plaster, as people imagine it on apartment walls today. It could have been a mineral mixture with sand, lime, stone dust, natural additives, and binding agents. After drying, such a composition could produce a dense surface resembling sandstone or limestone. And if polishing, coloring, aging, and centuries of dust were added, distinguishing it from real stone would become extremely difficult. This applies to those details that look too delicate for aggressive impact work. Petals, inner edges, deep cavities, curved transitions, all of this is far more logical to create in a material that is still responsive to the hand and tool. Then the craftsman has a chance to correct a line, remove excess material, add volume, smooth an error, and avoid destroying the whole section with one strike. There is another point that is usually ignored. If a dome was worked for a long time with hammer and chisel, not only traces of shape should remain, but also traces of method. Impact carving leaves character, rhythm, cuts and marks of removal. But when the surface looks too unified and almost plastic in its logic, the question appears, was there really a long impact process there at all? That is why the argument about vibrations, cracks, and joints cannot be brushed aside with a beautiful phrase about ancient skill. Skill matters, but it does not cancel physics. A blow remains a blow, stone remains stone. A joint remains a weak point. And if the surface looks as if it appeared as one continuous layer, then the version of a layer must be considered honestly. Then the Indian domes stop being just a mystery of patience. They become possible evidence of another building culture, one that knew not only how to cut stone, but also how to create material for carving. And if that is true, what stands before us is not merely the decorative luxury of temples, but the trace of a technology that was later too conveniently replaced by the tale of hammer, chisel, and endless years of labor. If we remove the beautiful tale of decades of manual labor, a much more sober version appears. Work like this may not have taken half a craftsman's lifetime, not 20 or 30 years, but a far shorter period. 1 or 2 years of intense, well-organized work, and that no longer sounds like fantasy, but like normal production logic. Especially if the task was not to carve every petal out of dead stone, but to work with a material that, at the right moment, was plastic. The key point is this: ancient construction was not necessarily slow simply because it was ancient. That is a convenient myth for those who do not want to examine the technology. If the craftsman knew the composition, if they had templates, If the work was divided into sections, if each specialist was responsible for one fragment, then the process could move quickly and accurately. Not for centuries, not for generations, but within clear time limits that made sense for the patron, the temple, and the community. This applies to the kind of work where the result depends not only on the strength of the hand, but also on the right material. Modern bas-relief masters understand this principle perfectly. First, the surface is prepared. Then a plastic layer is applied. After that, the relief is shaped quickly while the composition has not yet hardened. Only later does the material become solid, durable, and visually similar to stone. This logic changes the whole picture. If the work is done on a hard block, every millimeter has to be struck away, scraped out, leveled, and constantly protected from chipping. But if the work is done on a fresh composition, the craftsman is not fighting the stone. He is controlling the form. He can press in a line, pull out a petal, create a recess, remove excess material, and correct an edge. This is not painful chiseling. This is fast, artistic, and technical shaping. That is why a period of 1 or 2 years for such a complex of work stops looking bold. If a team of craftsmen worked on the site, if the dome was divided into sectors, if each sector was treated at the right moment, if the composition was prepared in batches, then the decorative finish could advance very quickly. One section is applied, one section is shaped. The next day, another section. Step by step, the entire dome becomes a luxurious carved surface. This applies not to primitive construction, but to organized craft production. Ancient masters could have had their own marking methods, their own proportions, their own tools for repeating identical forms, their own recipes for mixtures, and their own strict rules of work. There is no need to imagine them as random men with hammers in their hands. It is far more reasonable to imagine a school of craftsmen where everyone knew what to do, when to do it, and how much time remained before the material set. Modern relief artists work in a similar way. They do not wait decades for beauty to appear. They use technology. They apply a layer. They work on the fresh mass. They create volume. They refine the form. After drying, they sand, tone, strengthen, and receive a surface that can look like stone, metal, ancient stucco, or natural rock. Why then could ancient craftsmen living inside a temple-building culture not have possessed their own version of such a technology? This is exactly where the usual version begins to look poor. We are told they had plenty of time, but it is far more logical to ask, what if they had not just time, but a precise method? What if they did not sit under the dome for years with a chisel, but worked quickly while the material allowed the form to be shaped? What if the secret was not endless patience, but a composition that turned into a stone shell after hardening? This applies to the most important turn in the whole subject. If the possibility of a plastic composition is accepted, many oddities disappear. The speed of work becomes easier to understand. The delicacy of the details becomes easier to understand. The absence of crude impact marks becomes easier to understand. The dome no longer looks like tortured stone, but like a complete decorative surface planned from the beginning. 1 or 2 years is not a small amount of time, it is a huge working period for a coordinated group of craftsmen. In that time, an enormous amount of work can be completed if the process is organized correctly. And if every day is spent not on a senseless battle against stone, but on precise shaping of a fresh layer, the result could be exactly this. Fast by the standards of ancient construction, expensive, impressive, and almost incomprehensible to later generations. Then a completely different picture appears before us. Not decades under the sound of a chisel, not helpless faith in patience, not a legend about people who simply worked slowly and endlessly. Instead, a craft system where material, timing, sequence, and the price of error were understood. First, preparation. then application of the composition, then quick carving on the soft mass. After that, hardening, finishing, perhaps polishing, and imitation of real stone. Such an approach does not diminish ancient masters. On the contrary, it makes them far more powerful. A true master is not someone who merely pounds stone for decades in torment. A true master is someone who knows how to make the material work for him. And if Indian domes were created in this way, then their mystery is not endless time. Their mystery is a technology we have refused to notice for far too long. A layer of plaster is applied to the wall, and then the process is no longer a brutal battle with stone, but precise work on a material that is still alive. While the composition remains plastic, the craftsman can cut, press, pull, deepen, level, and build the relief almost like a sculptor, working not with a stubborn block, but with a mass ready to accept form. This is why the modern technique of bas-relief is so important for understanding Indian temples. It shows that a complex ornament does not necessarily have to be carved out of hard stone for years. Today, similar compositions can be found in specialized construction stores. The packaging often openly says, bas-relief, decorative plaster, relief mass, sculptural compound. The craftsman applies the material to a wall or ceiling, waits for the right density, and begins the work. First come the large forms, then the recesses, then the fine lines, edges, petals, transitions, and final refinement. This applies to the very core of the technology. The material must be soft enough to be shaped, but dense enough to hold its form. If the mixture is too liquid, it will flow. If it is too dry, it will crumble and tear. So the real secret is not only in the hand of the master, but also in the recipe of the mixture, the setting time, and the exact moment of processing. Modern mixtures often use organic polymers. They make the mass more convenient, adhesive, elastic, and predictable. But that does not mean the idea is impossible without polymers. On the contrary, mineral compositions based on lime, gypsum, or cement can perform a similar task if the filler, binder, and drying conditions are chosen correctly. Sand, stone dust, lime, and fine mineral additives can turn an ordinary layer into a dense, stone-like surface. And here the usual version takes another hit. If today a master creates a complex bas-relief, not by chiseling granite, but by carving into a fresh composition, why must the ancient master be forced into painful hollowing by default? Why is he forbidden to know mixtures, proportions, material plasticity, and setting time? This is a convenient ban that exists only in the mind of the modern observer. This applies not to fantasy, but to craft logic. Any building culture that raises temples for centuries inevitably accumulates knowledge about mortars, plasters, coatings, and decorative layers. Craftsmen observe how lime behaves, how a mixture hardens, how the surface changes after drying, how additives affect strength and texture. From such observations come not random tricks, but stable technologies. Let us imagine the process without unnecessary romance. First, the dome surface is prepared, leveled, cleaned, perhaps scratched or roughened for adhesion. Then a working layer of mineral mass is applied. Before it fully hardens, the craftsman quickly shapes the ornament, draws out petals, deepens cavities, emphasizes lines, creates shadow and rhythm. After setting, the surface becomes solid, and with the right composition, almost indistinguishable from carved stone. This method explains what the hammer and chisel version explains badly. It explains the delicacy of the details. It explains the repetition of the pattern. It explains the possibility of working on a ceiling. It explains why the surface can look continuous, without crude joints and without traces of constant impact struggle. And most importantly, it explains the speed. This applies to those domes where the relief looks too plastic, too smooth, and too confident for long chiseling out of a stubborn block. Where the form seems to have been drawn from a mass, not torn from stone. where every curl seems to say, here they worked not only with hands, but with knowledge of the material. And if ancient Indian masters possessed such a technology, then what we see is not a mystery of primitive labor, but the trace of precise construction chemistry from the past. Modern stores sell ready-made mixtures, but an ancient craftsman did not need factory packaging. He needed a recipe, experience, and a school. He could know what sand to choose, how much lime to add, how to strengthen the layer, when to begin carving, and when to stop. And then the thing that today is too often called impossible could happen. Stone beauty was created not by striking an eternal monolith, but by working a composition that first obeyed the tool and then became hard as stone. When we speak about the strength of such a composition, another detail appears, and it changes the whole discussion. Liquid glass, a water-based silicate solution, can be added to an ordinary mineral mass, making the surface denser, harder, and more resistant after setting. And the mocking question immediately weakens. How could such plaster last for centuries? It could, if this was not a weak domestic coating, but a strong engineering mixture prepared according to a precise recipe. Liquid glass is known as a material that can speed up hardening, strengthen the structure, and reduce surface looseness. In modern construction, it is used for protection, densification, moisture resistance, and bonding of mineral bases. Ancient craftsmen, of course, could have called a similar component by another name, obtained it in another way, and used different proportions. But the principle is clear. A substance is added to the mixture that turns a soft mass into a strong, stone-like shell. This applies to the most important technical side of the hypothesis. If the decorative dome was made not by direct carving into a hard block, but by working on an applied composition, then the craftsman had a limited working window. The material could not remain soft forever. It had to hold its form quickly, otherwise the petals, cavities, and thin edges would simply sag under their own weight. And here appears a number that sounds very practical, about 30 minutes for one segment. Not for the whole dome, not for the entire temple, not for the enormous ceiling at once, but for the specific area that had been applied and prepared for shaping. Within that time, the craftsman had to cut the lines, deepen the cavities, form the edge, refine the symmetry, and leave the surface in a condition that would not require rough correction after setting. 30 minutes is not romance, it is a strict working regime. This time limit immediately explains why the process could have been organized by sectors. One area was mixed, applied, and shaped. The next area was done separately. Step by step, the entire dome was formed not chaotically, but as a technical system where hand speed, prepared templates, proper moisture, exact density, and the discipline of the team all mattered. This applies to work where every mistake is expensive. If the composition sets quickly, the craftsman has no right to think for too long. He must know the pattern in advance. He must understand the depth of the cut. He must see the future form before the tool even touches the surface. That is why such a technology requires not random talent, but a school, experience, and strict transfer of skill. And here the version of simple plaster turns into a much more serious assumption. We may be dealing with a composition that was first plastic, then quickly gained strength, and after full drying became a dense decorative layer. Such a material could be carved at the right moment, but after a short time it began to resist like real stone. So the craftsman was not working for years on one spot. He was catching the brief moment when the material still obeyed the tool. If sand, stone dust, lime, mineral inclusions, and a strengthening component like liquid glass were added to the mixture, the hardened surface could acquire the necessary texture. It could become rough, dense, grainy, resembling sandstone or old limestone. And after finishing, drying, dust, soot, moisture, and centuries of aging, such a surface could merge completely with the image of real stone. This applies to the main deception of the eye. We see stone texture and automatically decide it must have been carved out of stone. But texture does not prove method. Modern decorative masters easily create surfaces that imitate marble, concrete, sandstone, old masonry, and natural rock. So the very idea of stone imitation is not fantasy. The real question is how well ancient craftsmen knew their own recipes. It is especially important that rapid strengthening allowed the work to move without long delays. There was no need to keep a section unfinished for months. There was no need to hammer finished masonry. There was no need to destroy material in order to create form. A layer could be applied, shaped during the right 30 minutes, left to set, and then the team could move on. That may be how the very carving that now looks impossible was born. Then the dome stops being a mystery of brute force. It becomes the result of a precise schedule: when to mix, when to apply, when to carve, and when to stop. What matters here is not only the artist's eye, but also the sense of time. This is not slow stone hollowing. This is a struggle with minutes, moisture, thickness, and the moment of setting. Such a method could have required enormous discipline. One person applies the composition, another holds the marking, a third shapes the main lines, a fourth refines depth and edges. Someone watches the mixture, someone prepares the next batch. All of this must happen quickly, without fuss, but with iron precision. That is why such knowledge could have been a closed craft secret, not an ordinary technique available to every mason. If strengthening additives were truly used in this technology, then what stands before us is not a decorative whim, but full-scale construction chemistry of its time. Without factories, without labels, without modern laboratories, but with practice, experience, and understanding of material. And this explains far more than the convenient legend of endless chisel strikes. Strength, speed, and delicate detail require not only hands, but also a composition that works together with the master. Today, no one is surprised when a modern craftsman makes a bas-relief on a wall out of plaster. People calmly look at relief panels, decorative ceilings, imitation stone, stucco, complex patterns, and three-dimensional compositions. No one faints because the material was soft at first and then became hard. Everyone understands the basic logic. There is a composition, there is a technique, there is an experienced hand, and there is the right moment for shaping. But as soon as the same principle is moved into antiquity, a strange panic begins. No, they could not. No, they did not know. No, only hammer, chisel, and endless years under a ceiling. Why? On what basis is an ancient craftsman denied the right to understand materials, mix compositions, choose fillers, and work not by brute force, but by technology? This applies to the most dangerous habit of modern thinking, seeing ancient people as talented but technically helpless. They are allowed to endure, drag stones, strike blocks, and pray for a result. But for some reason, they are not allowed to think like technologists. They are not allowed to have recipes. They are not allowed to experiment with mortars. They are not allowed to pass craft secrets from generation to generation. The picture becomes absurd. If today a craftsman applies a plastic composition to a wall and after a few hours receives a bas-relief, this is called normal craft. If an ancient Indian master could have done the same, it is suddenly declared fantasy. Modern man seems to have placed himself at the top of history and decided that everything before him must be rough, slow, and primitive. But the ancient temples of India shout the opposite. Their columns, ceilings, and domes show not blind roughness, but discipline of form. There is symmetry, repetition, precise plasticity, and a deep understanding of decorative rhythm. This does not look like random work by people who simply hammered stone until it became beautiful. It looks like a school, a system, a set of methods that were known, protected, and applied with cold precision. This applies not only to India. In different ancient cultures, there were complex plasters, mortars, paints, binders, polishing methods, artificial coatings, and imitations of costly materials. People knew how to work with lime, sand, clay, stone dust, and mineral additives. For centuries they observed what cracked, what held, what hardened faster, and what produced the right texture. From such observations, not accident, but technology is born. The most convenient word for a lazy explanation is primitive. It can cover any gap. Primitive tools, primitive methods, primitive society. But why then does the result not look primitive? Why do the domes not resemble a rough attempt to decorate stone, but instead look like a carefully designed decorative system? Why does every new fragment raise more questions than ready answers? And here comes the main provocative question. Do we really think the ancients were stupid? Seriously. They built temples, calculated loads, organized teams, created complex ornaments, passed down craft secrets, and worked with stone, wood, metal, and mortars. But the moment stone-like plaster is mentioned, they are suddenly denied even basic engineering intelligence. This applies to our arrogant habit of confusing the absence of modern factories with the absence of intellect. An ancient master did not have packaging from a construction store, small print instructions, or a glossy label. But he could have had experience, a recipe, a tradition, and hundreds of trials. He did not need a modern brand to understand that one mixture crumbles, another holds shape, a third hardens faster, and a fourth looks like stone after drying. That is why the version of a plastic composition does not look weaker, but stronger than the usual tale of a lonely craftsman with a chisel. It does not make ancient masters helpless, it makes them intelligent. It gives them back the right to technology. It explains why the work could be delicate, fast, continuous, and still durable. It shows that the wonder may not have been endless patience, but knowledge of the material. The modern view is often crude. If we do not know the exact ancient recipe, then it did not exist. But this is poor logic. Many craft secrets disappeared, together with workshops, families, schools, and temple traditions. Some things were never written down, some were passed orally, some were known only to a few people. And when the chain of transmission broke, later generations were left only with the result, and helpless astonishment before it. The Indian domes may be exactly such a case. We see a magnificent surface, but we do not see the workshop. We see the relief, but we do not know the composition. We see the stone texture, but we do not know whether it was carved or shaped. And instead of an honest question, we too often hear the self-confident answer, "They simply hammered it with a chisel for a long time." Too simple, too convenient, too poor for such work. If modern bas-reliefs made from plastic compositions surprise no one, then the idea itself is not madness. What looks mad is something else. The stubborn desire to portray ancient craftsmen as people who were allowed to endure, but not allowed to know. And perhaps knowledge was their main tool. Not the hammer, not the chisel, not endless years, but a precise understanding of material that we later lost and now try to replace with beautiful legends. Why are we so confident that ancient craftsmen could not know compositions that behaved like stone? It is a very convenient position. Declare everything complex to be the result of endless labor, and leave everything technological to the modern age. But history itself strikes at that arrogance. It is enough to remember ancient Egypt, where reliefs, plasters, painted surfaces, and complex decorative layers were not rare luxuries, but part of a major building culture. The Egyptians did not simply stack stones and paint pretty pictures over them. They knew how to prepare bases, apply leveling layers, create smooth surfaces, cover them with pigments, strengthen decorative elements, and turn walls into enormous fields of information. Temples, tombs, palace spaces, all of this required not only an artist, but but also a technologist. And if such a culture existed along the Nile, why could similar knowledge not exist in India? This applies to the most important historical argument. Ancient civilizations worked not only with hands, but with materials. They knew that one mixture held better, another cracked, a third was suitable for painting, and a fourth worked for relief. Such knowledge does not appear in a single day. It is born from hundreds of trials, mistakes, successful recipes, and strict transmission of experience. Look at Egyptian bas-reliefs. There is not merely a drawing, but work with surface, depth, line, color, and layer. The master had to understand how to prepare the plane, how to achieve adhesion, how to make the painting hold, and how to keep the relief from being damaged by moisture, time, and load. This is not the level of random craft. This is discipline that requires practical chemistry, even if the masters themselves did not use that word. And here comes an unpleasant question for supporters of overly simple versions. If the Egyptians could possess complex plaster and decorative technologies, why are Indian masters denied the same right? Why are some ancient peoples allowed to be clever engineers, while others are left only with a hammer, a chisel, and patience? Where is the logic? This applies to a common mistake. We often judge the past not by the result, but by our own idea of the past. If an ancient temple stands before us, we expect a primitive method in advance. But the result is not primitive. The result is bold, precise, dense, technically inconvenient, and far too complex to be explained by a single phrase. They simply worked for a long time. Ancient Egypt shows that plaster in antiquity was not something miserable or secondary. It was an important working material. It was used for leveling, surface preparation, painting, decorative effects, and imitation of a more noble base. That means the very idea of a stone-like coating that could be worked on is not a modern invention. If masters could create reliefs, cover them with color, and preserve compositions for centuries, then they understood the behavior of the layer. They knew the moment of application, the moment of processing, and the moment of drying. They understood that the material first obeys the hand and then becomes a hard carrier of the image. Is that not the same principle that may explain part of the Indian domes? This applies not to the direct copying of Egypt by India, but to a broader thought. The ancient world was full of technological solutions that we too easily call primitive today. Different cultures could arrive at similar methods independently. Where there is a temple, a patron, a workshop, a relief, and a demand for durability, sooner or later work with compositions appears. It is especially important that ancient craftsmen did not separate art from technology the way we often do. For them, a beautiful relief was not just inspiration. It was mixture, tool, timing, moisture, surface preparation, strength, and trained judgment. If even one element failed, beauty would not last. So behind a magnificent surface stood not only the artist's hand, but strict craft discipline. In this context, Indian carved domes no longer look like an isolated mystery that fell from the sky. They become part of a larger, ancient tradition of working with surface, relief, and artificial stone effects. Egypt provides an important precedent. The ancients could know more than we usually allow them to know. And if one ancient center possessed such methods, there is no reason to automatically deny similar knowledge in another. That is why the example of Egypt is dangerous for the dull version about a single chisel. It shows that antiquity was not a technical desert. There were materials, recipes, workshops, schools, methods, and secrets. And when we look at Indian temples, we should not ask the lazy question, how did they hammer the stone for so long? It is far more honest to ask another question, what composition, what method, and what forgotten school may have stood behind this luxurious stone illusion? A similar technology of artificial stone imitation could very well have existed in ancient India. And this does not look like a wild guess if we look not at myths, but at the temples themselves. Indian craftsmen worked for centuries with stone, mortars, pigments, polishing, decorative layers, and extremely complex plastic form. They did not create random ornaments, but entire stone worlds where every column, every arch, and every dome obeyed a strict ornamental order. If the Egyptians had their own compositions for preparing surfaces, painting, and relief work, why should India have been limited only to the crude path of hammer and chisel? Why should a civilization that left behind grand temple complexes be denied the right to its own construction chemistry? This is far too convenient a simplification. It turns the ancient master into a strong worker, but takes away from him the most important thing: technological thought. This applies to the very core of the version. Indian domes may not simply have been carved, but formed on a stone-like layer. Such a layer could have been applied to a prepared surface, then worked while it remained plastic, and after hardening, it could become almost indistinguishable from natural stone. Then the fantastic carving stops being a miracle of senseless patience and becomes the result of a precise craft system. Ancient India was not a desert of primitive techniques, but a space of complex crafts. There were schools of builders, carvers, sculptors, ornament masters, and people who understood proportion, rhythm, material, and sequence of work. Temple architecture required not only inspiration, but organization. A dome covered with dozens of delicate elements cannot be created if there is no discipline, calculation, and transfer of experience behind the work. It is especially important that the Indian decorative tradition always tended toward density. The surface was rarely left empty. Stone turned into a stream of figures, lines, plant motifs, geometric patterns, and symbolic forms. Such richness itself would push craftsmen to seek more convenient methods of work. If every element had to be carved from a hard mass, the process would become torment. But if part of the ornament was shaped on a plastic composition, the task became technically reasonable. This applies to temples where the carving looks too unified, too complex, and too even for the ordinary explanation. There is no sense of a random set of decorations. There is a single logic of the surface, as if the master worked not with separate pieces, but with one decorative shell. Such a shell could have hidden joints, leveled the base, and given a field for fine treatment. One can imagine how this happened. First, the base of the dome was prepared. Then a mineral composition with fillers was applied, creating a stone texture after drying. Then a master, or a team of masters, quickly shaped the ornament on the fresh layer. Petals, recesses, inner lines, edges, transitions. After setting, the surface became hard, and after finishing, it looked like real stone carving. This version explains why the work could be complex, fast, and durable at the same time. It does not require belief in the impossible years of chiseling every detail under a ceiling. It does not require ignoring the risk of cracks, joints, and defects. It offers a harsher and more technological picture. Ancient craftsmen may have known compositions that allowed them to create stone beauty faster and more accurately than we usually think. This applies not to fantasies about magic, but to the ordinary logic of craft. Where there is a huge demand for relief, where there are patrons, temples, schools, and generations of masters, methods for speeding up work inevitably appear. No one will spend decades doing what can be completed in a year or two with the right material, especially when the object is sacred, meant to impress, function, and display the power of its sponsors. So transferring the hypothesis to ancient India does not look like a weak assumption, but like a completely logical step. Indian masters could have possessed a technology of stone-like plaster, mineral composition, or artificial decorative layer. They may not merely have imitated stone, but created a surface that, centuries later, would be perceived as carving on a monolith. And if that is true, the main secret of the Indian domes is hidden, not in the endless sound of a chisel, but in a recipe that was once known, protected, and perhaps lost. If a modern bas-relief is given sharper forms, strict symmetry, and the right texture, it quickly stops looking like a new decorative piece. Add sand, stone dust, mineral grit, achieve the grain of sandstone, and what stands before us is no longer ordinary decorative plaster, but a surface the eye can easily accept as ancient carving. This is where the most uncomfortable point for the usual version begins. The appearance of stone does not prove that we are looking at a carved stone mass. Today, craftsmen can create imitations so convincing that a person without a laboratory and serious experience will not distinguish them from natural material. A wall made to look like old limestone, a niche made to resemble sandstone, a column finished as aged stone, a decorative panel styled as an ancient frieze. None of this is rare anymore. If the work is crude, the imitation is obvious at once. But if the master controls the rhythm of the form, selects the grain, creates chips, darkening, worn areas and transitions, the surface begins to deceive even a careful eye. This applies to the main trap of perception. We trust our eyes too quickly. We see a stone texture, so we decide it must be real stone. We see a complex ornament, so we decide it must have been hammered out with a chisel for years. But a decorative surface can look ancient, dense, and heavy, even if, at the moment of creation, it was a plastic mass. If a modern bas-relief is stripped of the softness of amateur stucco, the picture changes sharply. The lines must become stricter. The petals must be thinner. The recesses must be deeper. The repeated elements must be more accurate. Add mineral filler, make the surface not smooth but grainy, slightly uneven, similar to sandstone that has passed through centuries of dust, moisture, and touch. Then the result comes dangerously close to what we are used to calling ancient stone carving. The most important thing here is not just form, but the behavior of light. On ancient domes, ornament works through shadows. Thin edges cast dark lines, cavities create depth, curls produce movement, and repeated elements gather into a single rhythm. A modern master working with a plastic composition can achieve the same effect. He does not have to carve every millimeter from a hard block. He needs to shape the relief correctly before the material hardens. This applies to the details that mislead the viewer most easily. Clear symmetry seems like proof of stone carving. Rough grain seems like natural rock. An aged surface seems like proof of deep antiquity. But all of this can be created technically, through composition, texture, processing, drying, sanding, toning, and time. That is why the comparison between ancient and modern bas-reliefs is so dangerous for the simple version. It shows that the visual border between carved from stone and formed to look like stone can be almost invisible. Especially after centuries, when the surface darkens, gathers dust, loses freshness, receives small damage, and begins to look like one old material. Then the eye no longer asks how it was made, it simply surrenders to the effect of antiquity. If modern craftsmen can imitate sandstone, limestone, marble, concrete, and old masonry, why could ancient craftsmen not imitate stone carving in a temple? Why do we recognize such cleverness in today's decorative school, but deny it to those who built sanctuaries for centuries and worked with materials every day? Again, we get a strange logic. Modern man can do it, the ancient master cannot. But the temples say the opposite. This applies to the very core of the hypothesis about the Indian domes. Perhaps what we see is not deception in a cheap sense, but the highest skill of imitation. Not a poor substitution, but an expensive technology. Not an attempt to hide weakness, but a way to achieve extraordinary complexity of form without destructive years of hammering. This approach does not make the temple less valuable. On the contrary, it shows that the masters controlled not only the hand, but also the material. Imagine a decorative element. At first, it is soft, responsive, alive. The master draws the lines, deepens the cavities, forms the edges, creates repetition, adds grain. Then the composition hardens. The surface is sanded, perhaps toned, trimmed in some places, aged in others, and left naturally rough where needed. After decades, it already looks like old stone. After centuries, like an ancient mystery. That is why the phrase, "You would not distinguish it from ancient work," is not a decoration, but a serious technical challenge. If modern bas-reliefs, with the right refinement, can look like old carving, then appearance alone does not close the question. We need composition analysis, layer structure, tool traces, microcracks, and boundaries of the base. Without that, the confident claim, "This was definitely carved from a monolith," looks far too bold. Indian temples may preserve exactly such a secret, not only the art of the carver, but also the art of the stone imitator. Masters may have created a surface that did not simply decorate the dome, but forced later generations to believe in only one method of manufacture. And the most provocative conclusion is simple. Perhaps for centuries we have admired not only stone carving, but artificially created stone that proved more convincing than stone itself. Unique knowledge was rarely placed in the square, like goods at a market. It was protected, hidden, and passed quietly, from master to apprentice, from father to son, from an older carver to the one who stood beside him for years and at first only watched. High-level craft has always been a closed world. Secrets were not handed to every passerby, because a secret was bread, power, and protection for the workshop. If a technology of stone-like composition truly existed, it did not have to be written in large books for future guides. It could have lived in memory, in gestures, in proportions, in the habit of the hand. How much sand to add? When to introduce the binder? What layer could hold a thin petal? At what moment the material no longer flowed, yet still obeyed the tool? This is not a dry instruction, but a craft school that cannot be understood from one finished dome. This applies to knowledge that survives only while the chain of transmission survives. One master teaches another, that one teaches a third. Then comes war, a change of power, the ruin of a workshop, the loss of patrons, the collapse of temple economy, and the chain breaks. The result remains on the ceiling, but the method disappears with the people who held it in their hands. That is why even temple keepers today may not know exactly how it was done. They may know legends, names of gods, restoration dates, stories about kings and donors, but the technological secret may not have belonged to temple memory. It may have belonged not to priests or keepers, but to a narrow group of craftsmen who arrived, worked, and left behind not written records, but a surface. The most dangerous mistake is to think that if a modern guide cannot explain the technology, then it never existed. On the contrary, that silence may be the trace of loss. A craft does not disappear loudly, it does not slam the door, it simply stops being passed on. The last person who knew the recipe leaves, no apprentice appears, the workshop closes, and a century later, descendants are already arguing whether it was possible at all. This applies not only to India. History is full of crafts that once looked eternal and then vanished almost without a trace. Recipes for pigments disappeared, polishing methods disappeared, alloy secrets disappeared, techniques for working wood, stone, metal, and mortars disappeared. Sometimes the object remained, but the path to it was lost. And then, later generations began inventing convenient explanations. They worked for a long time, they had great patience, they were simply geniuses. But genius without technology is a beautiful emptiness. If we see a dome with the finest relief, then there were rules behind it. Not random inspiration, but a sequence of actions. Not a lonely master with a magical hand, but a closed system of skills. Preparation of the base, composition of the mixture, moment of application, rhythm of processing, method of strengthening, and final refinement. Such a system cannot be restored with one phrase. They were skilled. This is why the rarity of such masters matters so much. Specialists of that level could not have been numerous. They were not recruited in crowds from the street. They spent years learning to see form, feel the material, hold the tool, and understand the timing of setting. One wrong apprentice, and the secret moves away. One generation without transmission, and the technology turns into a shadow. This applies to closed craft lines where knowledge was not public property, but family or guild capital. As long as patrons, temples, and money existed, the workshop lived. When the era changed, taste changed, demand vanished, or patronage broke down, such a workshop became unnecessary, and with it vanished what had once seemed natural to a few initiated people. So the phrase, "temple keepers will not tell how it was done," does not sound strange. They may simply not know. Before them stands the same stone dome, the same carving, the same mystery. But between them and those masters lie centuries, losses, rebuildings, forgotten recipes, and broken lines of apprenticeship. The stone remained, the method moved into darkness. Then the Indian domes become not only monuments of art, but monuments of a lost profession. Perhaps this work was once understandable inside a narrow circle. Perhaps a master looked at such a ceiling and saw not a miracle, but a familiar sequence of operations. For us, it looks impossible because we see the final result, but not the school that created it. The harshest conclusion is simple. Ancient masters may have known what later generations stopped understanding. Their secret did not have to survive in textbooks, museums, or official explanations. It could dissolve in the silence of craft families, closed workshops, and forgotten recipes. What remains for us is only the luxurious surface above our heads, and a version far too poor, built on hammer, chisel, and endless patience. Perhaps there are still people in India who know how such work was really done. Not in tourist brochures, not in loud guidebook legends, not in pretty phrases about an ancient wonder, but in living craft practice. Somewhere in workshops, near temples, on restoration sites, among families of carvers and builders, fragments of that very knowledge may still survive. Not the entire system, not the complete ancient recipe, but separate methods, gestures, proportions, ways of preparing a composition and working on a surface. And this assumption looks far more reasonable than absolute confidence that the secret vanished without a trace. India is a country where temple craft has not become only a museum display. Temples are still built, decorated, restored, carved, modelled, polished, tinted, and filled with old forms. There are modern temples with carved columns, decorative ceilings, and complex ornaments that continue an ancient visual tradition. That means somewhere close to this tradition, old technological moves may also have survived. This applies to places where restoration is not a formal painting of a wall, but a real continuation of craft. When a master does not merely cover a crack, but understands the material. When he knows which mortar holds an edge, which mixture gives the right grain, how to make a surface look like old stone, how to repeat a texture so that the new section does not shout against the ancient one. Such knowledge rarely enters textbooks. It lives in the hand. Perhaps one of these masters today could explain part of the mystery without any mysticism. He might say, first the base is prepared, then a layer is applied, then the right moment must be caught while the composition still accepts the tool but no longer flows. Then comes quick shaping, then setting, refinement, trimming, sanding, and toning. That is all. What looks to the viewer like an incomprehensible stone miracle may be, for the master, a chain of exact operations. But would such a master reveal every detail to an outsider? That is the question. A craftsman is not required to expose his livelihood. He may show the result, but hide the proportions. He may name the general principle, but not reveal the important additive. He may smile, nod, and say, "This is how the elders did it." And the conversation ends there. Workshop secrets do not become public property simply because a tourist or researcher wants a clear answer. This applies to the closed nature of craft, especially where knowledge was passed not through departments and patents, but through years of observation. First, the apprentice carries materials, then he mixes the mortar, then he cleans tools, then he works on an invisible section. Only years later is he trusted with a complex fragment. In such a system, the main recipe is not written on paper. It is built into habit, hand speed, feeling of moisture, and understanding of the moment. Indian temples with modern carving and restoration may be the key to this subject, not because they necessarily repeat ancient technology exactly, but because they show that the tradition of surface work has not completely broken. Where there is modern work, there are masters. Where there are masters, there is experience. Where there is experience, traces of old methods may remain, even in altered form. The most provocative part of this story is that the answer may not be in archives, but in the hands of living people. Not in offices where people argue about dates and styles, not in dry catalogues where a dome is described as carved stone, but in a small workshop where a person mixes sand, lime, mineral dust, water and additives, then calmly does what the official version tries to explain through decades of chisel blows. This applies to the final question: are we looking for the secret where it is convenient to look, or where it may actually have survived? Perhaps there should be less distant admiration and more attention to restoration technology, modern temple workshops, and people who still work with relief, because they may preserve not a legend, but a practical remnant of old knowledge. And if such masters truly remain, they do not necessarily look like guardians of a great sensation. They may be ordinary workers, carvers, restorers, decorative finishers. They may not pronounce loud words about ancient technologies, but in their hands may live what once created the domes before which modern explanations now spread their hands helplessly. So this story does not end with a full stop. It remains open and even irritatingly alive. Perhaps the carved Indian domes are not only a mystery of the past, but also a question to the present. Perhaps part of the answer can still be found, not under layers of dust, but among those who know how to work with stone, plaster, mineral compositions, and temple surfaces today. And if that is true, the main secret is not completely lost. It is simply not placed in a display case, not written on a plaque, and not spoken into a guide's microphone. What remains before us is a hard and beautiful version. Ancient masters may not only have cut stone, but created stone. They may have shaped the surface, strengthened it, given it texture, and left later generations with the illusion of a monolith. And somewhere in India, perhaps, there are still people who know this path not from books, but from work. As long as that possibility exists, the version of one hammer, one chisel, and endless years of labor looks far too poor for the greatness of these temples. If this version made you look at Indian temples differently, give this video a like. It helps the video move forward and shows that viewers really need these uncomfortable topics. Subscribe to the channel if you want to see more stories about forgotten technologies, strange traces of the past, and mysteries that have been explained for far too long with convenient phrases. And be sure to hit the bell so you do not miss new episodes, because what comes next may once again make the familiar picture of the past begin to crack.